Hi, ladies, Mr. O'Sullivan. Today we're going to be looking at 3-6 mega equations. There is no delta math today. It's just going to be this edPuzzle assignment. So please, please, please pay very close attention. And as always, make sure that you are writing down how we solve these problems. If you have any questions after this lesson, email myself, Miss Townsend, Miss Jimenez, the usual people. Okay, let's begin. So today's learning target is I can write the equation of a line by applying my knowledge of properties of lines. So we're going to be looking at y equals mx plus b again today. Before we begin, you can graph this information on a graph to see what's going on. So if you have your graph paper, take it out. Ways to find slope. If they give you 2 points, you can graph them, then count up and down, then left or right. That's going to give you your rise over your run. This is the graphical approach. Rise and run. Or you can do the average rate of change or your slope formula, which is y2 minus y1 over x2 minus x1, or just subtract your y's and subtract your x's, which is the exact same thing as saying delta y over delta x. If they give you the equation, solve the equation for y first to get its slope. Don't worry about parallel or perpendicular. We're not really going to go into that this year. Hoivux. So I'm going to cross this stuff out. We're not going to go into that at all this year. We'll go into that next year in geometry. Hoivux. These are your special lines. The ways to tell if a line is special. The slope is a 0 in the numerator or the denominator. So like your answer after simplifying will be 0 in the numerator or 0 in the denominator. The problem tells you that your line is vertical or horizontal, or if there's only one letter in your equation. Remember, special lines do not follow the normal rules of equation writing because you're always just going to get x equals a number or y equals a number. Writing the equations of a line, remember, you just need a slope and a point, and you always put your equation into y equals mx plus b, substituting your favorite point, and then solve for b. Practice exercises. So for these next, given points and all that stuff, and we want to graph it and write the equation in slope-intercept form. So the first thing I'm going to do is I'm going to plot these points. Remember, my quadrants are plus plus. Let me zoom in. Minus plus, minus minus, plus minus. And everything's in relation to your origin. So the first I'm going to plot as my negative 3, 4. So I go out 3, up 4. 1, 2, 3, 1, 2, 3, 4. That's a point. I'm then going to plot negative 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now I'm going to draw a line connecting those points in red. And remember, after you draw a line, you put arrows on it, and boom. Since I have 2 points already on my grid, what I'm going to do is I'm going to do the rise over run approach, and then I'm going to show you how to use the formula. So I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going up 10, and I'm going over 2. So I'm running 2. So remember, slope is equal to rise over run. So I rose 10, and I ran 2. So that means my slope is 5. Now I'm going to show you how you can do it using y2 minus y1 over x2 minus x1. So you can just simply substitute your y2 and your y1. So I get negative 6 minus 4 over negative 5 minus a negative 3, which gives me negative 10 over negative 2, and negative 10 divided by negative 2 is a positive 5. So you could have done it that way, or you could have done the rise over run approach. So I know equations are written in y equals mx plus b form. So y equals mx plus b form. I know my slope is 5, so I'm going to plug in a 5. And now if I look at my graph, I don't have my y-intercept. My y-intercept would be somewhere on this line, but it's not drawn. So what I have to do is I have to actually algebraically solve for my y-intercept. So I can choose either point. I can choose my negative 3, 4, or my negative 5, negative 6. I'm going to choose my negative 3, 4 because I don't want to work with only negative numbers. I'd rather work with a positive number. So I'm going to write that down, negative 3, 4. The negative 3 is my x value, and the 4 is my y value. So everywhere I see an x, I plug in negative 3. Everywhere I see a y, I plug in a negative 5. I mean a positive 4, sorry. So I have 4 equals 5 times negative 3 plus b. 5 times negative 3 is going to give me a negative 15, so I have 4 equals negative 15 plus b. The only way to get rid of that minus 15 is to add 15 to both sides. My 15s cancel, so I get b is equal to 19. Now that I have b is equals 19, I can rewrite my equation with my 19s. So y equals 5x plus 19. And that's your final answer. Let's do a few more. We're going to be looking at 4 situations, and we're okay, a line that passes through 0, -1, and -2, -2. So I'm going to plot 0, -1, and -2, -2. 1, 2, 1, 2. I'm going to draw my line in red, and I have my line drawn in red. Again, I'm going to do the slope by using rise over run because I'm graphically drawn, because remember, we want to write the equation, and we know our equation's written in y equals mx plus b form. M stands for your slope, B stands for your y-intercept. So if I look at my visual, I'm rising 1, and I'm running 2. So I can say my slope, which is equal to rise over run, is just going to be 1/2. And that's my slope. I can also use the formula. Let's see, try to do the formula by yourself. I'll put up the solution. So when I do my slope formula way, I still get a 1/2, so I did it correctly, so don't stress. So now I look at my equation, and I know it's in y equals mx plus b form, so I'm going to rewrite it. Y equals mx plus b. We found our slope to be 1/2 in both situations, so I can write y equals 1/2 x plus b. And now I'm going to look at my graph to see if I have my y-intercept. Well, look, I do have my y-intercept. I have my y-intercept right here at -1. So I can just go ahead and put that in. Y equals 1/2 x minus 1. And that's your final answer. Please don't write plus -1. It's a little messy. Okay. Now what we're going to do is we're going to plot the points 2, 4, and 2, -6. 2, 4, 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5, 6. And now we're going to draw a line going through those points. If you look at this, after plotting it, I have a straight line going down. That's a special case. This is a Hooy-Vooks situation. So I'm going to do Hooy-Vooks. So if I look, this is a vertical line. So I can actually just say that this is a x equals. So I look at my points just to make sure it's an x equals. I look and I see that I have a 2 and a 2 in my x values. They're both the same. I just have different y values. So I can say the equation is, I can say my equation is x equals 2. And you're done. Now let's go on to the next example. We're going to plot the point -3, -4, and 4, 3. So I go to the left 3 and down 4. So 1, 2, 3. 1, 2, 3, 4. Now I'm going to go out 4 and up 3. 1, 2, 3, 4. 1, 2, 3. I'm going to draw a line going through those points. So I have my line drawn in. Remember, I want to write the equation of the line in slope-intercept form. So I want to write it in the form y equals mx plus b. M is your slope. B is your y-intercept. So looking at my graph, I can find the slope by using the rise over run approach. So I rise, let's see how far I have to rise to come into line. So I rise 1, 2, 3, 4, 5, 6, 7. And I run 1, 2, 3, 4, 5, 6, 7. I run 7 as well. So my slope of rise over run is 7 over 7, which reduces to 1. Now I'm going to do the exact same thing I've been doing before. I'm going to pause the video. I'm going to find the slope of these 2 points by hand to show you that it's still going to reduce to 1. Look, I just did the slope by hand, and I was able to get 1. I did 3 minus the -4. 4 minus a negative 3, got 7 over 7. 7 over 7 reduces to 1. So when I write my equation, y equals mx plus b form, I have y equals mx plus b. We just said our slope was 1, so I'm going to put in a 1 for m. So I have y equals 1x plus b. But now I need to find my y-intercept. And look, I crossed my y-axis right here at negative 1. So I could say my y-intercept is negative 1. And that's your answer. Y equals 1x minus 1. Or you can just write x minus 1. Okie dokie, artichokey, let's find the equation of a line provided a graph. Step 1, identify nice points on your graph, aka no decimals or fraction. So I'm going to use green. I'm going to zoom in. This is not a nice point, so I'm not going to plot that. This is a nice point. This is a nice point. This is a nice point. So I have 3 nice points, but you only need 2. Most of the time you will just have 2. On delta math, you're going to have a bunch. He's very nice. Now, we identified our nice points. Count your rise and your run. This will give you your slope. Remember, is your slope positive or is it negative? So I'm going to do my rise and my run. So I'm going down 1, 2, 3. I'm going 1, 2. So I'm going right 2, down 3. And I can show you, I can even use these 2 points. I can go down 1, 2, 3. And I can go right 1, 2. So my slope each time is negative 3 over 2. Remember, y equals mx plus b. Slope, y-intercept. So my slope for this example is negative 3 over 2. Because that was my rise and my run. My y-intercept is at a positive 4. That was step 3, find your y-intercept. Now step 4, put it all together. Write your equation in y equals mx plus b form. So we said our slope was negative 3 over 2, so I'm going to plug that in for m. We'll substitute. So y equals negative 3 over 2. I put my x, and I put my y-intercept of plus 4. That's it. Let's do some more. 2 more graphs, then we're going to do some tables of values. Remember, the first thing we do is we plot our nice points. So I'm going to plot them in black this time. This is a nice point right here at my origin. This is a nice point right up there. I don't see if... Ooh, and here's a nice point. Okay, so it looks like our slope's going to be a big number. So I'm just going to go from here to here. So I go down 1, 2, 3, 4, 5. And I go to the right 1, 2, 3. So my slope is rise over run, which in this case, I'm rising negative 5, and I'm running 3. My y-intercept is where I cross the y-axis. I cross the y-axis right here. That number is a good old 0, so I can say my y-intercept is 0. So when I put my equation together, my equation would be y equals mx plus b. This goes in for m, this goes in for b. Y equals negative 5/3 x plus 0. If you want, you can just write it as this. You can just write it as y equals negative 5/3 x. Or you can write it as negative 5/3 x plus 0. It's not a big deal. Now let's go on to our next example. First thing we do is we plot our nice points. This is a nice point. I don't see any of them to the left. This is a... Where's the next nice point? Oh my god, there's only 2? That's annoying. So we plotted our nice points, and now what we're going to do is we're going to count our rise and our run. Remember, slope is rise over run. So I go up 1, 2, 3, 4, 5. and I go to the right. 1, 2, 3. So my rise over run is 5 over 3. Cool, wasn't that in the other example? Oh, it's negative 5/3. Ooh, this is fun. Okay, so now we know our equation is y equals mx plus b form. M is our slope, b is our y-intercept. So remember, we just said our slope was 5/3. We now need our y-intercept. So if I look, my y-intercept is right here. This is where I cross the y-axis. It's not 2, it's not 4, it's 3. So my equation with my b equals 3 will be y equals m is 5/3 x plus my y-intercept of 3. And that's your final answer. Okie dokie, artichokey. Let's go on to writing the equation of a line provided a table of values. Now this is some fun stuff. If you're given a table of values and you verify that the table represents a linear relationship, aka there's a constant rate of change, then you can find both the slope and the y-intercept from the table. Well, you can find this y-intercept from the table most of the time. Sometimes it's actually just easier to substitute and solve for it, but that's besides the point. Step 1, calculate the change in y and the change in x. When I say that, I simply mean just do this by figuring out how much you jump to get to the next value. Then find your y-intercept by using algebra or by examining your table of values. Remember, your y-intercept is when x equals 0. So the minute you see x equals 0 in your table, I want you to circle it or highlight it. That way you know that's where your y-intercept is. So for our first example, we want to write the equation of a line for the table of values below. The first thing I do is I calculate my jumps. So from -2 to 0, I go up by 2. Look, I'm putting a positive 2 because I'm going up by 2. 0 to 2, I go up by 2. 2 to 4, I go up by 2. 4 to 6, I go up by 2. Now, I'm going to change up the color. -4 to 2, I actually go up by 6. 2 to 8, I go up by 6. 8 to 14, go up by 6. 14 to 20, I go up by 6. If you look, I'm going up by the same jump each time for my y's and the same jump each time for my x's. I know my slope is the change in y over the change in x, so I can say my slope is just going to be 6 over 2. Six divided by 2 is 3. So my slope for this table is 3. Remember, y equals mx plus b. M is your slope. So I have y equals, I put in my 3 for m, so I have y equals 3x. And remember what I say, whenever you see x equals 0, I want you to circle it, and that's your y-intercept. So my y-intercept is 2. So the equation for this table of values is 3x plus 2. And that's your final answer. Now practice. Given the table of values, write the equation of a line. Okay, so let's go through it. From -2 to -1, I go up by 1. -1 to 0, I go up by 1. 0 to 1, I go up by 1. 1 to 2, I go up by 1. This is looking good so far. I like this. 80 to 70, I go down by 10. Look, I'm putting a negative this time. 70 to 60, I go down by 10. 60 to 50, I go down by 10. 50 to 40, I also go down by 10. Remember what I said, my slope is the change in y over the change in x, so I basically just do blue over red. So my slope is going to be -10 divided by 1. -10 divided by 1 is -10. So my slope for this table of values is -10. Remember, y equals mx plus b. I said the minute you have an x equals 0, you got to circle it. My y-intercept is 60. So my equation for this is y equals -10 x plus 60. And that's your final answer. Number 2. I'm gonna do my y's first, 'cause I don't typically do those my y's first. I go up by 5, go up by 5, go up by 5, and go up by 5. Now let's calculate our jump index. 1, 1, 1, and 1. I keep on going up by 1 and I keep on going up by 5. I like it. Remember, your slope is the change in y over the change in x. So I can say my slope is 5 over 1, which means 5 divided by 1 is 5. So remember, y equals mx plus b. It's your best friend. So my slope is what I'm going to put in for m. So I'm going to put in a 5 for m. So I have y equals 5x. But now I need to know what my y-intercept is. So I said go to x equals 0. But if you look, there is no x equals 0 in my table. So here's what you can do. If I'm going up by 1 in my x's, I can go back by 1. So if I go back by 1, I'm actually taking away 1. What's 1 minus 1? It's 0. If I'm going up by 5 each time, if I want to go backwards, I got to subtract 5. So what's 5 minus 5? It's 0. So my y-intercept for this function is actually 0. So my equation would be y equals 5x plus 0, or just y equals 5x. And that's your final answer. You could do it another way. You can plug in your favorite point into this 5x plus b. So pretend you have y equals 5x plus b because you don't know what your y-intercept is. You don't know what your y-intercept is. Pick your favorite point. I'll pick my 1 and my 5. That's your x, that's your y. So I'm going to plug in my 5 for y. So I have 5 equals 5 parenthesis 1 because that's my x value plus b. 5 times 1 is 5, so I have 5 equals 5 plus b. Get rid of that 5 by subtracting, and you get b equals 0. And look, I just solved for my y-intercept. Okay, that's it for today. If you have any questions, email myself, Miss Townsend or Miss Jimenez. No delta math, just this edPuzzle. Have a great day, ladies.